This is lecture 16 on equivalence relations. It's a part of a pure math course called Finite Group Theory at junior and senior level. And the first author of the text that I use is Barnard. And here's the text. It's in the Teach Yourself series. And the title is Mathematical Groups. If you want more details on the text, prices, how to get it from Amazon.com if you're buying it in paper form, or if you want it in electronic form for free, how to get it from emule.com, this kind of thing, then go to my website, prof, just short for professor, Hugo deGaris, that's my name, .wordpress.com, and then click on the tab deGarisMPC. MPC stands for Math, Physics and Computing, because I plan to do hundreds of courses over the next decade or two or three, if I live long enough, to provide free education at advanced levels, mostly graduate level, so M1, first year master's level, M2, second year master's level, PhD 1 and PhD 2, so to quite high level in pure mathematics and mathematical physics. One of the things I'm trying to do is to provide a free education to the planet, as well as killing off the monstrosity that parents, for example, who send their kids to Harvard, for example, have to pay out about $40,000 a year for that child's intuition, which is just crazy. In the modern world, the technological means exist today, like handycams, YouTube. You can store multiple gigabytes of videos for free that the world has access to. That kind of thing. So I label myself a free prof. I'm a professor giving free lectures because I think education should be free, and now that it can be free, it should be free, so we can get rid of this $40,000 a year abomination. Now that's threatening to a lot of people, of course, because that will mean their jobs, but it will liberate students from expensive tuition, and two, it will give them a choice, because there will be lots of free profs, free professors in the future, so the students can choose the best ones and get a better education. Alright, okay, so this particular topic on equivalence relations is a stepping stone towards the next lecture, lecture 17 on chapter 17 of this text. And that's one of the highlights. It will be one of the highlights of the whole course, because it's on quotient groups, or the same thing, factor groups. There's two labels for the same concept. And basically that idea is from a group, under certain circumstances, you can extract a smaller group. So that smaller group is the result of a kind of division of the larger group. And that concept gets used a lot in future finite group theory, and especially in mathematical physics, in theoretical physics. The idea of a quotient group, very important. Alright, so what we're going to learn in this lecture, this session, is the concept of an equivalence relation, because we'll need it to understand the theory of next lecture on quotient groups or factor groups. Alright, so equivalence relations. Now before I explain what an equivalent relation is, perhaps I should start with what a relation is, because an equivalence relation is just a special kind of relation. So let's start with a more general notion, and then motivate the discussion about an equivalence relation. Okay, so what is a relation? Well, it's some kind of, now this is rather vague, but deliberately, A relation is some kind of connection, or relationship if you like, between elements of a set. So the relation holds between, let's say, two elements of a set. So you have element A and element B, both members of a set, and there's some sort of connection between them. And if that's so, you can say that there's a relation between A and B. Now that's a bit vague. Let's do some examples of that. Some connection, some relation between two elements of a pair. One relationship might be, is the father of. So A, member A of the set, might be the father of the second member of the set, B. Okay? Or A might be older than B, or the same age as B, or A likes B, or A has the same family name as B, or in a mathematical context, A equals B, or A is greater than B, or A is less or equal to B. You know, that kind of thing, right? So you know, if this sort of thing exists between two elements in a pair, you say a relation exists between these two elements, you know, in a set, right? A, B belong to this set, big A, right? Now you could write, and you can write it anyway. I've written it this way. So if there is some kind of relation between these two elements of your set A, we could write it this way, like big R for, you know, there is a relation between A and B. Now note, it's an ordered pair. The order matters. So A, R, B might be, it depends on R, but it might be different from B, R, A. So it's an ordered pair. So let's use these relations here as examples to see, you know, see if that's true. So, for example, if there's a relation between A and B, you know, A, R, B, does it follow automatically that B, R, A is also true? In other words, does the same relation hold between B and A? Well, it depends. It depends on what that relation is. For example, let's go through them. So if A is the father of B, is B the father of A? Of course not, right? B would be the son or daughter of A, right? So yeah, it doesn't hold. It doesn't hold for that one. If A is older than B, is B older than A? Of course not. If A is the same age as B, is B the same age as A? Yes, right? So it depends on the relation, right? If A likes B, does B like A? Not necessarily. You've probably heard of the term unrequited love, meaning love not returned, right? If A has the same family name as B, does B have the same family name as A? Yes. Okay, so it depends. Right, now what about A, R, A? Does a relation exist between A and itself? Does that make sense? Well, let's check it again. Now, is A the father of A? Can you be the father of yourself? No. Can you be older than yourself? No. Can you be the same age as? Yes. Does A like A? Maybe, but not necessarily. Okay. Does A have the same family name as A? Yes. Does A equal A? Let's say A is some number or something. Yes. Is A greater than A? No. Is A less or equal to A? Yes. Alright? So, you know, A, R, A, is that true in general? No. Depends on the R. Right? And similarly this way, it depends on the R. How about this one? If A R B and B R C, how about A R C? Well, let's do it again. Let's see if this is true. So given this and this, is that true? Well, let's say A is the father of B and B is the father of C. Is A the father of C? No. A is the grandfather of C. Right? So that's false. If A is older than B and B is older than C, is A older than C? Yes. In this case, yeah, for this R, this one, yes. If A is the same age as B and B is the same age as C, is A the same age as C? Yes. If A likes B and B likes C, does A like C? Not necessarily. You can have two pairs of friends that A likes B and B likes C, but A and C may have nothing in common. Right? So, no. If A has the same family name as B and B has the same family name as C, does A have the same family name as C? Yes. Okay? If A equals B and B equals C, does A equal C? Yes. If A is greater than B and B is greater than C, is A greater than C? Yes. If A is less or equal to B and B is less or equal to C, is A less or equal to C? Yes. Alright? So, you know, depending on what the R is, you might have this being true. You know, you have a kind of symmetry. You know, if A R B, then B R A. That's true in some cases, for some R's. Not true in general, right? There are R's where it's not true. How about itself? Is A R A? Is that true in general? No, depends on the R. Okay, and how about this one? Is that true in general? No, depends on the R. Okay, well, there's a certain category, a certain subclass, if you like, of relations. You know, here are a bunch of examples of relations. There's a certain category of them where all three of these are true. Like if ARB then BRA, and ARA is true, and if ARB and BRC then ARC. So possibility 1, possibility 2, and possibility 3, if all three are true for that type of R, for that R, that kind of R, where this is true, and this is true, that kind of R is called an equivalence relation. Right? And these are just general relations. They're just examples of a relation. But if you hear about an equivalence relation, that's a special kind of relation. It means that this R here, this will be true.